So in the previous video, we talked about how to find reference angle or angle theta prime. So it's going to tie into evaluating trigonometric function of any angle. So with this concept, the first step, step 1, find the reference angle theta prime. So again, from the picture, here is the illustration of reference angle or angle theta prime. Step 2, find the value of the trigonometric function for angle theta prime. Now, this is mainly in regards to the special right triangle, where it's sometimes 30 degrees, 45 degrees, or 60 degrees, even 90 or 0. So if your reference angle is one of those degrees, then you are able to give me the value of the trigonometric function, meaning evaluating the trigonometric function here. But keep in mind, those are only for special right triangles, 0, 30, 45, 60, and 90. But you should be able to determine, regardless of any angle, the value of the trigonometric function. Now moving to step 3, using the quadrant in which the terminal side of angle theta lies, determine the sign of the trigonometric function value of angle theta. So what it means that where the terminal side lies, even though you found the reference angle, finding the reference angle will help you find the value of the trigonometric function. The terminal side determines the sign, if it's positive or negative. So let's move on to this part of the next section. The sign of the trigonometric function in each quadrant can be determined using the function definition given on page 242. For example, because sine theta equals to y over r, it follows that sine theta is negative when y is less than 0, which occurs in quadrant 3 and 4. Using this same logic, you can verify each of the signs for sine theta, cosine theta, and tangent theta shown in the diagram. Notice that these values depend only on x and y because r is always positive. So, what I mean by that, if you were given a coordinate point, x and y, if x is negative, it can affect which function, sine, cosine, or tangent, being positive or negative, and y, if it's negative or positive, it can affect one or two or three function, sine, cosine, and tangent, where it can be positive or negative. R is always positive because if you follow the Pythagorean theorem, a squared plus b squared equals c squared, just like in the previous video where instead of using those letters, I use x squared plus y squared equals r squared. When we're working that out, r will always come out positive. Now, in the diagram on the right, where it's talking about quadrant 1, quadrant 2, 3, and 4, it tells you of the three main functions, sine, cosine, tangent, where if the terminal side lies in each of its respective quadrant, it'll tell you what's the sign of each function. So, quadrant 1, all three will be positive. Sine, cosine, tangent will be positive. Quadrant 2, only sine will be positive, but cosine and tangent will be negative. Quadrant 3, sine and cosine are negative, but tangent is only positive. Quadrant 4, sine and tangent are negative, but cosine is positive. Now, if you were looking at this on the x, y terms, respectively, so in quadrant 1, you see that your x values and your y values are positive. So when it's being divided, when you put in the ratio or the definition of the 6 trig functions, meaning where sine theta is y over r, cosine theta is x over r, tangent theta is y over x, regardless of any number, it's always going to come out positive. Now over here, quadrant 2, you see that your x values are negative numbers, but your y values are positive. So when it comes to cosine, which has x values, it's going to come out negative. Tangent will also use x value, it's going to come out negative. Now sine is going to be a positive number because if you look, we're only talking about in regards of the y-axis above or going up above the x-axis. Now, quadrant 3 is dealing with the x values on the left and y values at the bottom. So that means both of them are negative. So that's why your sine data will be negative, your cosine data will be negative. Now, your tangent data is positive because if you remember the definition, tangent data is y over x. So if your y value is negative, is being divided by your x value, which is negative. Negative divided by negative is positive. Quadrant 4, looking at the xy plane, x values are positive because it's on the right side. Your y values are negative because it's at the bottom. So sine is dealing with the y values. Since the y values are at the bottom, it's negative, sine data would be negative. Cosine data deals with the x value on the right side. So that's why cosine data would be positive. Now, tangent data is negative because while your x value is positive, your y value is negative. So, according to the definition again of tangent data, it's y over x. So since y is a negative number, being divided by x, which is a positive number, it's going to come out negative, which is why tangent data will be negative. Now, it's pretty a lot to memorize all this for quadrant 1, 2, 3, and 4. Now, there's a saying how to memorize this. So the saying is, all students take calculus. So if you take the first letter of each word, all, so in quadrant 1, all meaning all trig function are positive. My second word is student, so the first letter is S. So if you see S stands for sine, that's positive. My third word is take, the first letter is T, and using T for tangent, which is positive. The last word is calculus. The first letter is C, so we use C for cosine, that's positive. So if you memorize that saying, all students take calculus, you can remember which one is positive depending on which quadrant, and everything else will be negative. Now, typically I don't go with that saying. I would prefer all students take college algebra, that's more appropriate. But whichever saying you like, you can use. Now moving to the last part. Because you know the exact trigonometric values of 30 degrees, 45 degrees, and 60 degrees angles, you can find the exact trigonometric values of all angles for which these angles are reference angles. The table lists these values of theta in both degrees and radians. Now, in our first video for 4.3, I show you how to memorize in order to find exact values of sine and cosine of 0, 30, 45, 60, and 90 degrees. So here is another table. You don't have to copy, but it's just basically, most of the time we're going to be using this in our reference angle. Now, but pay very close attention. It gives you 30 degrees or its radian equivalents, pi over 6, 45 degrees or its equivalents, radians equivalents, pi over 4, and 60 degrees with its radians equivalent, pi over 3. So make sure you remember that. So again, you're not required to copy this table. It's just, it gives you the information of degrees and radians, but I do highly recommend to copy the row with the tangent data information. You should have information for sine data and cosine data, but you should copy down your radians equivalents for 30, 45, 60 degrees and the section for tangent data.